Okay, hello everyone. Today I would like to clarify the difference between law of large numbers, LLN, and central limited theory, CLT. And most people are easily mix these two up. And so I hope that I could help you to know the difference between these two. Okay. And before I begin this class, I have to suppose that all of you have already know what are population distribution, sample distribution, mean, variance, and normal distributions are. Okay. And I will start by giving you the definition of these two and give you an example for give you an example to illustrate it. Okay. And first, what is law of large numbers, LLN? And you can find a definition in your textbook or on the internet. Says, as your sample size n become larger, and then its sample mean will approach more to the population mean. And let me give you an example. If today I'm really interested in the average student size in the UMN, and of course my population will be all the students in the UMN, right? And because some of the reason like cost, and I cannot know all the students' height, so I cannot get the exact average student height. Okay, so I have to do sampling. I can choose to pick 10 people randomly for my population, and then I will get a sample mean height, right? Or I can choose to pick 1,000 people for my population, and then I will get the other sample mean height, right? And by the LLN, it tells us that the sample mean height with the sample size 1,000 will be more approached to the population mean, which I'm interested in. Then the sample mean with the sample size 10, only 10. Okay. I mean, if today I want to guess the exact average student height in the UMN with less arrow, I would like to, I will use the sample mean, okay, and with the sample size as large as possible I could. Okay. Second, let's talk about CLT. What is CLT? Central limited law. Also, you can find a definition in your textbook or by the other ways. Okay. As in sample size n, as your sample size n approach become very large, and then its sample distribution of sample mean will approach to normal distribution, with its mean equal to the population mean and its variance equal to the population variance over sample size n. Okay. And continue the example of the students' height in UMN. And because I want to get a sample distribution, so I have to do sampling many times. I mean, I will pick 10 people randomly from my population, and then I will get the sample mean, right? And now I take these 10 people back to the population and pick randomly 10 people again, and then I will get another sample mean, right? And I also put this back to the population and pick again and get the sample mean again, and put this 10 people back to the population again and pick again and get again. Okay, and I do it many times, and I will get the sample distribution of the sample mean with the sample size 10, right? Thus, I can say that each sample size have its corresponding sample distribution. Okay. So if there are three sample distribution with sample size 10, 100, and 1,000, and the CLT tells us that the sample distribution with sample size 1,000 will be more like normal distribution than the other two sample distribution with sample size 10 and 100. Okay. And last, you have to remember that because there is no assumption about population distribution in the CLT and LLN, so they are always be used widely in the advanced statistical proof. So I mean that it always work if that, even though I don't know the distribution, I don't know the exact distribution of the student height in the UMN. Okay, yeah, that's it, and thank you very much.